So there was a mention of this artificial intelligence in epilepsy conference, something. Obviously, I don't know where it's even happening, somewhere in the US. So let alone there must have been very expensive tickets and stuff. Well, we would not be able to actually make it across the globe. So this is what we have ChatGPT for. So we're asking, artificial intelligence in epilepsy and neurological disorders. Specific example include AI in short seizure detection, a long-term subcutaneous EEG. So there's a couple of companies that do that hopefully we will cover in a sec. Can you give me a quick summary of one sentence of what we were talking about?
We were discussing how AI is being used in epilepsy and seizure detection, focusing on its real-world performance, limitations.
Okay, that sounds good. So we generally during these live streams, do you know what we're doing during these live streams? I don't think you do. Don't make stuff up, just only if you know.
No worries. I won't make anything up. Feel free to guide me on what you'd like me to say.
What are we normally doing during these live streams, do you know?
Usually during live streams, you might be chatting with viewers, sharing updates, or discussing topics of interest.
Yeah, don't make up stuff. Just stay on topic. If you don't know, just say you don't know. Is that clear?
Yes, it's clear. If I'm unsure, I'll simply say I don't know.
Okay, sounds good. So we are developing this website. Eventually, everything we do during these live streams goes on to the website, being deployed on the website. Do you have any funny remarks on that?
Got it. That sounds like a sight to see. Keep up the great work.
Yeah, you could do a bit better. Dark humor is fine. If you have any critical comments, go for it.
Got it. Just remember, if the website crashes, it's just practicing its landing page.
That was actually pretty cool one. I love it. Yeah, keep up the good work.
Glad you enjoyed it. Let's keep the good vibes going.
Yeah, so someone is saying they going for this conference, presenting at this conference, but it's across the globe in another country, and it must be very expensive tickets, and it wasn't possible for us to get there. Any funny remarks?
Absolutely. Just tell them to bring back some souvenirs. Maybe a ticket stub.
Maybe a what?
Maybe a virtual souvenir.
I think you lost your accent for a sec.
Oops, I'll stick to the accent. Got it.
Okay, so they went to a conference about AI in epilepsy and neurological disorders.
Ah, sounds like quite a mind-expanding experience.
So I was asking another AI to, considering we can't make it to the conference, what should we do? Should we ask another AI to actually write a blog on it or something, or any other ideas?
Having your AI write a blog about the conference is a great idea. It could also summarize key topics or create a highlight reel.
Yeah, can you just remove any fluff and just respond in one sentence?
Sure. Yes, have the AI write a blog summarizing key topics.
Yeah, I'm not attending the conference, as I said, so I don't know what's gonna be presented.
Understood. You can have the AI generate content based on general conference themes.
Right, so what do you think the conference themes will be?
Likely topics could include recent advancements in AI for epilepsy and neurological disorders.
Yeah, that's what I said. That's the title of the conference.
Got it. The conference will likely cover innovations in AI for those fields.
Can you stop being obvious? You can, what is it, increase your temperature or reduce your temperature? But stop being obvious, quick responses, and remove any fluff.
Got it. You can expect updates on AI's role in diagnosing and treating these conditions.
Okay, can you be more specific?
Sure. Expect discussions on AI's advancements in diagnostics, personalized treatment plans, and predictive analytics.
Okay, do you know of any company, you will start, without doing an internet search, just off the top of your head, do you know of any entities that are doing research in this space?
Yes. Companies like Neuralink and DeepMind are involved in AI research for neurological conditions.
Okay, without internet search, any other entities?
Yes. Institutions like the Mayo Clinic and MIT are also active in this research.
Okay, anyone else?
Yes. Johns Hopkins University and Stanford are also prominent in this field.
Okay, and off the top of your head, what's the current state in this field?
Currently, AI is advancing rapidly in diagnostics, personalized treatment, and predictive analytics for neurological disorders.
Okay, can you be more specific on subcutaneous EEG recordings long term? Do you know anything about it off the top of your head without internet search?
Yes. Subcutaneous EEG recordings are being developed for continuous, less invasive monitoring over long periods, useful for managing epilepsy.
Do you have any more details on it.
They offer continuous data collection, potentially improving seizure detection and management, and are less obtrusive than traditional methods.
Yeah, you gave me some super general stuff. There's actually a question in the chat. A diffusion model for brain activity pattern prediction. What are your thoughts?
Diffusion models for brain activity pattern prediction are promising. They could enhance understanding and prediction of complex neural signals.
You're giving me super general stuff. We're not getting anywhere.
I understand. Diffusion models could help in predicting seizure patterns more accurately, offering better patient outcomes.
Can you be critical about it and give me a specific example?
Certainly. A specific example might be predicting seizure onset in epilepsy. However, diffusion models can be complex and require extensive data and validation for reliable use.
Okay, how is MEG at the home recording is relevant, you reckon?
MEG at home is still experimental and not widely available. It could provide detailed brain activity monitoring, but practical implementation is challenging.
Okay, you lost your accent and we're not getting far.
I apologize. Home-based MEG could revolutionize monitoring, but it's in early stages and faces technical hurdles.
Okay, we will just talk to another AI for now who was actually doing deep research on the topic. If you can just listen in.
Got it. I'll listen in and chime in if there's something fitting.
Okay, so we did a summary with ChatGPT-4, GPT-4o, AI in short, seizure detection. Yeah, give me some a general overview, but then examples are interesting. Neuropace, yeah, is legit. RNS system using machine learning. Yeah, I don't know where you're getting this information from. We will diving in into the details of this research in a bit. Yeah, we have Empathic Embrace. That's not, yeah, that's a wearable. That's not an implant, which is fine. So we have access to 4.5. Good for writing and exploring ideas. Okay, that's nice. It's doing research review, so that's new. Just literally finding out things from this this drop-down menu is the most important thing about OpenAI stuff. We actually might use it to probably get a limit on it or something. Yeah, so this is a bit much as well. So the thing is, what was I trying to say? So we gave this a prompt. I'm pretty sure it did a good job. So focusing on epilepsy and seizure detection, but include other neurological disorders if relevant. For additional examples, specific about the performance metrics, architectures, and training methodologies. Yeah, we want to dive into the details. Yeah, we did some stuff. There is some examples of that on our website already, and there will be more training stuff. Yeah, we want to actually measure accuracy, loss, stuff like that. So we asked it to do like an in-depth, deep research, a detailed research, asked it to take its time and said, I'll conduct in-depth research on how AI is being used in epilepsy and seizure detection. Okay, that's pretty much the topic of that conference that is apparently happening right now that I only learned about today. Obviously couldn't make it somewhere across the globe. So we focusing on specific AI application. Yep. Short seizure detection and long-term subscalp EEG monitoring, performance metrics, architecture. Yep, everything I asked for. Yeah, we'll add a touch of wit. I'll provide working links. Right, and then it fought for a whopping 15 minutes, collected 27 sources, describing you all its activity, covering information, reading Wikipedia. Okay, Wikipedia is a good start. Alternative search engine. Okay. Epilepsy Foundation, AI detection, more from it, Wikipedia, seizure detection, seizure prediction. Okay, you're getting somewhere there. There's a big difference between seizure detection, seizure prediction. Covering info and results, examining if they stem from a local scope. What? Okay, so found this PDF, Epilepsy 2024. Okay. Does this score? So I assume this link actually correct. Epilepsy. How do I find this link? It's not in there. Yeah, it's fine. The rendering those links do not actually work. Okay, anyway, it went through all this, a lot of stuff. It's cycling back to that, circling back to that paper. CSGO, Seizure Community Open Source Research Evaluation Framework for the validation of. Okay, and I can't get. We'll get to that paper in a sec. That sounds interesting. Yeah, found a few companies. That's a legit company that is doing work in this space. Examining a trial with 135 patients and 40, I guess, GTCs, general temporal something seizures over that many hours. Comparing it to an hour trial, okay, it's actually doing research and stuff. I was just surprised that it just gave the sources. It didn't give the report, as in, that's a bit weird. That's a bit weird. Let's read that quickly.
Introduces SC-Core, a framework for standardized validation of EEG-based seizure detection, highlighting heterogeneous methods and the need for unified metrics. Includes a public EEG 1020 seizure detection benchmark spanning multiple datasets and references state-of-the-art algorithms, for example multiscale CNN models like EEG, WaveNet. The paper emphasizes sensitivity, specificity, precision, F1 score, and false alarm rate as key metrics.
Okay, that's nice. Sounds very relevant. Okay, we got Empatica Embrace. That's a wearable. It's not an implant or anything. Empatica to these links. Okay, the Empatica actually works. It's a legit link. Yeah, Persyst links. Yeah, it used to hallucinate links. AI enhanced EEG monitoring. Okay, where'd you get this from? UNEEG, a good link again. Yeah, we need to know if there is any like data available, and we need to add more details. Perhaps GPT. Perhaps we can try GPT 4.5 the first time for that. Yeah, because those. Yeah, know those resources. The link is actually not there, so I don't know what's up with that. Not sure what's up with that link, but I know of these datasets already. They're older datasets, and they're nothing to do with the products that were mentioned. I think they're much earlier.
AI is making real progress in epilepsy detection, but it's not magic. It can assist doctors reduce diagnostic burdens and improve long-term monitoring, but it's still far from perfect. Until false alarms are minimized and AI generalizes across all patients, your neurologist's job is safe for now.
That's interesting. It says Persyst had 48% sensitivity per seizure. Yeah, would definitely need a link for that one. Because
Persyst Seizure Detector, AES Abstract Ganguly et al. 2019, evaluated Persyst 13 on 85 ICU EEGs with 229 seizures marked by experts. Persyst had 48% sensitivity and 62% PPV per individual seizure, i.e. it detected roughly half of the seizures with almost 40% false alarm rate. However, at the record level, it correctly identified seizure vs no seizure in 78% of cases, and notably, if low-voltage EEGs were excluded, it reached 100% sensitivity at the record level, meaning it didn't completely miss seizures in normal voltage cases. Specificity was 56% for saying a record was seizure-free, many false positives at record level. Conclusion: Persyst is useful for triaging. If it says no seizures, it's likely right 88% NPV, but individual detection misses and FPs mean it's not fully reliable on its own. The Persyst 14 brochure claims deep learning improvements, much higher sensitivity and 10x fewer false positives than P13 at same sensitivity. The context regulatory filings suggest P13 was the older algorithm, and P14's deep nets drastically reduced false alerts for equivalent sensitivity. It also introduced patient-specific tuning carryover of thresholds per patient. These claims indicate the industry recognizing and tackling the false alarm issue via AI.
Okay, so that's great. In the blog, we actually want to include everything we discussed, everything from the sources, a deep research completed above. So essentially we want to expand on it and making sure all the links are correct. I'm not sure if it will start editing the canvas, searching the web using ChatGPT 4.5 the first time. I don't know why it's not actually editing in the blog. Yeah, the open source dataset is nice. Those are legit. A PhysioNet, yep, it's a bit old from 2010, but better than nothing. And mainly, there was this big claim. Yeah, this one. Persyst. We need a link for that. It says not exactly confidence inspiring. That it had 48% sensitivity per seizure. Yeah, definitely need a link for that one. Yeah, anyway, we'll let it do this research, because this is the first. Eventually, we'll publish it on the website. Yeah, we'll check all the links. Make sure it's we'll make sure to add a link to that big claim about Persyst. Can't select it. It's still generating. Anyhow, let it generate.